things that we're talking about are called data structures. That's the big term. An array is a data structure. You know, it looks like, you know, obviously you've got numbers here and your data over there. An array list also looks like that, although technically that's an object, which points to initially nothing, but then you can add more onto it, because what they did is they really just wrapped an array or an object code around an array. A linked list, if you remember, is a reference to a list, but this list has data in here and then a reference to the next guy, which has data and then a reference to the next guy right here. These are called nodes. Each node has its own data plus a reference to another node. Okay? So that was linked list, array list, and array. Today we're going to talk about a stack. A stack is also a way that you have data, okay? And so it's a reference. But the best way of visualizing the stack is that it has limitations on it, okay? And the limitations are that the data resembles like a stack of books or a stack of plates, okay? Actually, you start off with an empty stack. And then you push one on, and then you push another one on, and these are papers, so it's going to kind of get messy. And then you push another one on, and the only thing that is visible to you is whatever is on top of the stack. You can't access every one of them. You can only access the one on top, and the way you access the one on top is by popping it off the stack. So I pop this one, and then oh, look, I'm looking at this book. Pop it off, and then if I want to push something else on, I can push that on, but now the only one that's visible is the last one that I pushed on, okay? An application that you probably are familiar with of this occurring is with the back button on your browser. When you hit the back button, what does it take you to? The last page. If you hit the back button again, it takes you to the one you were at before that. So the way that a stack works with web browsers is every time that you go to a website, it pushes the previous one onto the stack. And then you go to another website and it pushes the previous one onto a stack, like that. And then when you hit the back button, you pop it off. Can anybody think of another thing that you use almost every hour that resembles that? Kind of like a back button? What's the back button equivalent when you're writing a paper?
Backspace?
Backspace maybe, okay. I was thinking more of like undo. So anytime you do something, it pushes that operation on the stack. Then it pushes it on the stack. And then when you went to undo, you're not going to undo the very first thing that you did when you open up the document. You're going to undo the very most recent thing. So you can see that stacks play a very common role. And so the terminology is push data on, okay, and pop, to pop data off the stack. There also is a peek, which allows you to look and see what's on the top, okay? So if I had a stack called maybe ST, and I said ST dot push 5, then on my stack it would push the number 5 onto the stack. And I said ST dot push 3, it would push 3 onto the stack. ST dot push, I don't know, 9, it would put 9 on the stack. If I were to peek, what number would I see? 9. If I were to pop and store that value, I'll just say print st.pop. It's going to pop the 9 off, and it would print it. If I were then pop again, then I'd get the 3. Pop again, I'd have the 5, and my stack would be empty. Does that make sense? That's how a stack works. If you look at the code, or this is a very limited list of methods, I would say, a very limited API. You have isEmpty, peek, pop, and push. IsEmpty returns a Boolean, true or false, let you know if it's empty or not. Peek returns an item of type E, where E is the generic whatever this is a stack of. In my case, I've got a stack of integers, but you could have a stack of dogs or bank accounts or web pages. Pop is going to do that same thing. It's going to pop off and it's going to return E. And push, actually, you have to give it the information, which is why you can see I have push on the inside of those parentheses. That also will return that item, I guess, just for fun. Okay. Would y'all like to create a stack and do some of this together? All right, let's go and do that then. So I'm going to create a new Java project. I'll call this data type demos 2018. Call this one stack demo. All right. The stack is a class, so I'll just say stack, and then I need to give it the type, and it has to be a class. So that's why I'll type integer with a capital I rather than int. So I'll use a wrapper class. I'll give it a name. ST seems to make sense for these purposes. Equals new stack. Inside the brackets, I'll type integer. And so this is a class, so I'm instantiating an object of that stack class. So I'll put the parentheses there at the end to call the constructor. There is an error there, but that's just because I have not included the stack class from the Java util package. So at the top I'll just say import java.util.star. That'll take care of that. So st.push, let's make it like this. 539 5 st.push 3 st.push 9. System.println peek. Actually, peek is with 2 E's plus st.peek. Got her? All right, I'll send her up. Okay. Rosa to the office, ready to go. Dylan, go ahead and take it down the hall, plug it in.
I'm going to use my computer just to make sure it works before I do that.
Sounds good to me. Check those videos online, Rosa. They're all ready for you. Okay, works. All right, so peek and then 9. Do y'all have that as well? Any questions, any difficulties? All right, so what I'm going to do now is I'll pop one of those off, need more screwdrivers or anything to attach to the monitor, let me know.
Yes, sir.
Y'all get peak 9, peak 3? Okay. Let's go and push a few more values on there. st.push 20, st.push 50. Somebody make a prediction. What would the stack look like at this time? From bottom to top. Then
20.
Then okay, would y'all agree? 5's still on there. The 3's still on there because we were just peaking. We weren't really hopping. Sounds kind of weird to say it like that, but okay. There is a way to traverse a stack the same way that we were able to traverse the list and stuff like that. Stack is one of these collection items that is iterable, so we should be able to, with an enhanced for loop, walk through the entire stack, okay, and keep it intact. Now, technically, that's not the, I mean, it's almost like you shouldn't be able to do that. It's like, if they were really doing their job in a manner of speaking, the stack would only allow you to peek, pop, and push. You know what I mean? Like in a pure world, that's all you can do to stacks. And this is an important point for y'all to know. When the Java developer folks were creating the stack and the linked list and the array list, it was like, it was a big committee of people, and they're like, well, yeah, we should add this. Yeah, we should add this, and we should add this ability. What if they want to walk through the stack? Don't you think they should walk through the stack? I think they should, and so they added that. And there's a whole lot more of this stuff that I can't even that I don't even know about. But you can get a peek into it here if you hit st dot, and you can see all the other stuff that they added on there. Okay? It's pretty crazy. This is death by addition here, you know, just more and more and more. Now, some of these things are legitimately okay, but because of all of this code stuff like that, if you have a very large data set that you're trying to process data and you're using a stack, then every item in your stack that you create is going to have, you know, the stack is going to have a lot of code in it, and it's going to, and it can make your program run slower. In actual fact, what you can do is you could create your own stack class that doesn't have any of that extra stuff and just literally has peek and pop and push, and that's it. And it can't do anything else unless you wanted to, and then you kind of tell them what you want to happen. So anyway, I would like to, during second semester when we're doing our coding and stuff like that, get to the point where we create our own stack. Okay, I've got an awesome book. If those of you that are juniors and you want to take Programming 3, this book is unbelievable. Like, I'm still geeking out about it. And what's also really nice is that this guy, he teaches at Princeton, and all of his videos are online, like close-up face, voice in a microphone, then also the code. Anyway, totally amazing stuff. He walks us through a lot of that stuff, as well as how to deal with really large data sets and make it efficient. So much good stuff in that book. But anyway, there's all that stuff. All right, let's do an enhanced for loop really quickly so we can get to queues. We can say for each integer I in the stack, system.out.println I. Five, 3, 20, 50. As it turns out, you can create a stack with an array. There is one nice thing about this. We don't really see what's going on behind the scenes. We just, as far as we're concerned, we can push, we can pop, we can go through it with a for each loop. There's two main ways of implementing a stack. One of them is with an array. The other way is with a linked list. And I don't know which way that the Java library uses, but there are advantages for using an array as the code behind the code, and there's advantages of using a linked list as the code behind the code. That's the type of stuff second semester, maybe next year, that we would talk about. If this is kind of really, you know, ringing your bell, that sounds kind of interesting, then this is computer science stuff. This is computer science 2, computer science 3. So anyway, I see Jeremy, you're nodding over there. That's definitely a career field I think you would enjoy. All right, but for now, I'm going to comment that code out and show you an alternate way to walk through this stack. And we'll say while not st.isEmpty. So while it's not empty, system.out.println st.pop. So what that's going to do, it's going to say, is it empty? Nope. All right. Pop and print. 50. Empty? Nope. Pop and print. 20. 3. 5. It's empty. So we stop. So meanwhile here, we printed out 5, 3, 20, 50 based on just the internals of how it traverses with the for each loop. Here, it's popping them off. And as an added bonus, if I kind of look at it the way it popped off the 50, then the 20, then the 3, then the 5, and the way that it kind of prints out sort of resembles the way that the stack is, which I think that's kind of cool. All right, I told you stacks weren't difficult. That's pretty much everything I have to say about stacks. Okay? Let's talk about a queue. Q-U-E-U-E. It's actually a British word, which means a line. So my dad, for several summers, he would have a project that he would do with this company that they would send him over to England for. And so he developed all these different British idioms. He doesn't speak in an accent by any means, but he would say things like, queue up, queue up. He would tell it to us kids, and we're like, it means line up, you know, to my sisters and I. All right, get in the queue, get in the queue. It's just a line, okay? And while a stack follows a first on, last off, okay? A queue follows a first on, first off. I don't think that's really the word. I think it's first in, first out. First in, first out. So queue resembles this. Your data is getting added to the queue. Here's your data, here's your data. Sorry, it should look like this. Like you go into the queue, and another one comes into the queue, and another one comes into the queue. And then when it leaves with the remove method, the first one in is the first one out. Okay? The Marines are like a stack. They're the first ones in and the last ones out. Okay? There you go. It's kind of first in, Philo. First in, last out. I think that's kind of what they don't they say that? In the military? Yeah, I'm pretty sure they say that. Anyway, first one in is the last one out. Okay? A queue, now you gotta wait your turn. Okay? And there you go. For whatever reason, the folks at Java decided not to make a class for the queue. They just decided to make an interface. Okay? And you can see there it says interface queue. That's it. You say, well, how do I actually create one? Well, if you go up a little bit, you can the linked list class implements the queue interface. Okay? So with its add and remove stuff. So let's go ahead and I might comment all of this out. And I'll say Q, I'll just put the letter Q, equals new, oh, hold on, let me hit myself, Q bracket integer, Q equals new Q bracket integer So, wait a second. Cannot instantiate the type Q. Oh. Why can we not instantiate a Q? Because it's an interface. So over here I'll say linked list. Remember, if the variable is a Q variable, it can point to a child, or it can point to a class type which implements that interface. Like parents can point to their children, kind of thing. The children can't point to the parents. So it's a new linked list. So if I type Q dot, I should have an add. There you go. So add, let's add 7. Q dot add 42. And Q dot add 3. Do we have a Q dot peak? Oh, see, we've got a Q dot peak. We got all kinds of stuff. Technically, well, they don't tell you what's available on the queue, but what do you think is going to happen if I say Q dot peak?
7 is going to show.
Let's find out. Yep, it's 7. And then I can say Q dot remove. And then I'll peek again. And we're looking at 42. Couldn't make sure you get the code in there if you wanted. So peek one time, got 7, then 42, then 3. So, God. 7, then 42, then 3. Then I wiped off the 7, 42's there, and the 3, I guess you could say. And we could add more. I'll just add 2 more, I guess. Q dot add 2, and Q dot add 70. No, sure. And 700. Now, these are Java. These are data types that Java has actually already gone and they've coded and things like that. When I was in college, which is when I first started learning about these, that's kind of cool that you get to learn about them in high school. And even in that other book, they talk about not just the data type, which is what all of these things are, but they talk about the ideal data type or the abstract data type. Sort of like, what in a perfect world, what would this data type do and not do and things like that. And when you talk about the abstract data type of Q, they use the words NQ and DQ. That's the more sort of fancy language. Java decided not to go that route and just say add and remove, make it more manageable for us Yankees. All right. Although I don't know any Texan that would readily call himself a Yankee, but Yanks. That's what the British call us. Anyway, so there you go. We can do that. Shall we traverse it with a for each loop? We can. I guess we might as well. We've only got this plus one more, so we can traverse it with, we can say for each int I in Q system.out.println I. And you can see that when it prints out the 42, then the 3, then the 2, then the 79. And so there's the for each loop. We can also, I'm going to copy this code that's somewhere up here, this while loop. While it's not empty, but I'll change, instead of st, I'll say while Q is not empty, print Q dot remove and that's going to remove them in order. The first one that it's going to remove is the one that's at the front of the line, 42. Then it's going to remove the 3, then it's going to remove the 2, then it's going to remove the 79. All right, so that's a queue. Any questions? Okay. So the only thing left is a priority queue. Now, what do you think a priority queue is all about? Cody? Priority queue. When you think of the word priority, what does that imply? First, okay. So some sort of ordering, right? You ever been in line and you're like, well, these people know I've got places to be. I'm more of in a rush than that person is. I should be able to go in front of them. Okay? You selfish person. Anyway, well, that's what a priority queue does. A priority queue, when you are inserting numbers in there, the queue itself says, where should this one be inserted? Oh, this is a small number. That needs to go up at the beginning. Ooh, this is a large number. That's going to go at the end. And it will sort it according to what the data that's already in there. Okay? So it does it automatically. I don't know, I think it uses an insertion sort. Because it's sort of like you already have sorted data, you just need to insert this one into wherever it doesn't use insert sort, it just inserts it into the proper place. Okay? So let's go ahead and demonstrate that. You do not need to tell a priority queue to prioritize itself. It does it automatically every time you put some data in there. So we'll say priority queue PQ. Oh, I need to tell what type. Integer. PQ equals new priority queue integer, open parent, close parent. That's a mouthful. The priority queue class is a class, so we can create an actual instance of it. So just to be ridiculous, we'll say pq.add99, pq.add86, pq.add 56, and then system.out.println will peek again plus pq.peek. And if this was a regular old queue, we would see the one that was inserted, that was added first, which would be the 99. However, cross my fingers, we look at it and boom, there it is, it's showing the 56. So if we remove that, if we say pq.remove, and then look at it again, we'll see that there's now 86. Probably should add a few more. pq.add. So I'm not going to remove those now. I'm going to say pq.add 70. pq.add something between 86 and 99. So 95. pq.add 1. pq.add I don't know, 60. So all sorts of values there, and I'll just copy that while loop, adjusting, say while PQ is not empty, system.out.println PQ remove. And what we would expect is that as it's going to be removing them, it's going to be removing the lowest one in the list. So this should be the equivalent of like sorting the data. 1, 56, 60, 70, there you go. That's great. This is beneficial in all sorts of contexts, okay? If you have, I mean, your operating system is doing this based on what's the user looking at now, okay? If you have limited resources, limited RAM, limited CPU usage, how does the computer know, do I deal with this, or do I deal with this, or deal with this? Well, which one's in the foreground? Which is the user looking at right now? Process that stuff first. Deal with the other stuff later, okay? Stuff on updating those other windows or whatever. That's just one way that priority queue works, or could be used. It's also great if you have a constant set of data coming in, okay, and you want to prioritize based on the data that you already have, but you don't want to like get a bunch, then sort it, then pull this one, get a bunch of sort it. It takes care of all that itself. The best way I could, like a good analogy would be like an emergency room, okay? An emergency room, for the most part, it's first come, first serve. Unless you come in and you're bleeding with, gunshot wound to the chest and you're gonna die in like 2 minutes. You get put to the front of the line. Are we doing good?
Test it.
I need to test it? Okay. So, that concludes priority queues, stacks, and queues. Some of the more advanced UIL computer science programs can become a snap if you utilize these data structures.
I tested all the ports already, to make sure that no one can have access to it.
Let's grab a mouse and go on a field trip, gang.